Imagine you've just joined a team of developers working on a cutting-edge web application. As a seasoned IT enthusiast and fresh IT recruit aiming to excel in Python, let's dive into the real-world application of efficient data manipulation, focusing on dictionaries. Python dictionaries, powerful and flexible, have a myriad of optimizations and tweaks we can apply, especially for enterprise-grade applications dealing with massive datasets. Now, Python, often referred to as the beating heart of data manipulation and analysis, offers us a collection of built-in data structures, among which dictionaries stand out for their versatility and speed. As we start exploring the vast applications of dictionaries in Python, we realize their strength is not always in their speed, but in our ability to wield them with finesse. In Python 3, dictionaries are implemented using a hash table, providing, on average, an impressive O lookup time. However, maintaining this speed requires a well-thought-out strategy, especially when handling large datasets where Python dictionaries can become slow, if not managed properly. Let's unravel some of the strategic enhancements we can apply to improve the use of dictionaries and ensure their effective admixture within critical sections of our application. Let's start by understanding Python's dictionary from the internals, focusing on how it handles collisions. When two keys hash to the same index, a dictionary utilizes a technique called open addressing, with methods like linear probing, quadratic probing, and double hashing. Choosing the right strategy can significantly reduce clustering issues and subsequent lookups within our dictionary. In our application, where speed is key, we will likely benefit from double hashing to minimize contention and maintain performance. It's essential to keep our keys consistent, using immutable objects like integers, strings, or tuples as keys maintains reliability. For enterprise-grade applications dealing with mutable data, creating tuples from mutable objects and using these as keys is crucial. This practice enables us to enjoy the benefits of fast and direct access to values using these now fixed references. But remember, dictionaries have their downside; they can be memory hogs. Implementing a cache with an underlying dictionary can optimize for scenarios of repeated lookup for a large dataset. However, in Python 3.8 and beyond, we have functools.lru_cache available, easing the labor-intensive aspects of manually setting up an LRU cache. Furthermore, the default dictionary in Python's collections module allows us to initialize dictionaries with a default factory function, ensuring type-specific values by default, which reduces the chances of key errors, increasing the efficiency and reliability of our application. Now let's bring it back to dictionaries of dictionaries, or dicts of dicts, which are akin to a container within a container. Using an appropriate data structure for the outer dict optimizes search times, especially when our inner dicts grow in size. We should ponder upon whether maintaining data in a flat structure makes sense in our use case, or a one-level nested dictionary might suffice, keeping our lookup times efficient. Iterating over dictionaries is ubiquitous, yet if we only need values, key lookups, or key-value pairs, we can optimize our loops. Utilizing the values, keys, or items methods not only makes the code concise but also expedites access times, especially helpful in traversing through configuration objects, settings profiles, and cache data. Python's dictionary is dynamic, meaning we can add, remove, and update entries on the fly. But when this dynamism leads to frequent changes in the dictionary size, it could impact performance. For our application, where datasets evolve over time, we should keep an eye on the dictionary size. If the size grows significantly after certain operations, using alternative structures which handle dynamic resizing better could be worth the consideration to preserve performance. Python dictionaries also enable a mapping of unique objects to singleton instances, allowing for sophisticated caching patterns. Exploiting this could dramatically reduce memory usage, as well as speeding up our application by caching expensive computations, which is perfect for our data processing pipeline. Another key is profiling our code when using dictionaries, running benchmarks and utilizing profiling libraries such as cprofile or the more Pythonic %timeit in Jupyter helps identify hotspot sections. Knowing the time complexity lets us adjust our dictionary usage to suit our performance targets, which will result in refined code, more readable and maintainable. Finally, integrating Python dictionaries in our application with serialization protocols like JSO ensures seamless interchange of state, crucial for microservices that must store and recover state information. Now, to ensure that we've captured the essence of this tutorial, allow me to summarize the best practices and tips we've discussed. Choose the right collision strategy to reduce lookup time in large datasets, double hashing. Standardize keys to remain immutable to maintain cache consistency, using structures like tuples formed from mutable types. Leverage functools.lru_cache, simplifying manual cache control. Prefer default dict for initializing dictionaries with uniformity to prevent key errors. Select the appropriate iteration method best suited to your specific requirement, values, keys, or items. Manage dictionary size dynamics by evaluating if a more flexible structure like a B-tree might better fit our evolving datasets. Embrace Python table map pattern for an optimal structure when dealing with nested dictionaries. Profile and refactor dictionary usage to achieve better performance and readability. Use serialization protocols like JSO to maintain dictionary state across systems or components. By incorporating these finer points into our daily coding life, we can elevate the efficiency of our Python scripts, applications, and projects. As we wrap up this exploration into mastering dictionaries in Python, remember, the key lies in understanding the details that underpin these tools' performance and implementing best practices in your code. Now go forth and wield dictionaries with prowess in your next enterprise-level Python endeavor. Visit neeraj.qzz.io to never miss our TechLab updates, and don't forget to subscribe.